Hey everybody, this video is going to be about the claims that we make and the observations that we measure and gather data on, and how it relates, it corresponds to the biblical claims of the earth, and which is these are all basically, if you're trying to explain something, you have to be able to, if you're going to propose a worldview, you have to be able to explain something. To be able to explain something is how we're able to do things like make predictions, and be able to learn from what happens when you have two causes, what's the effect, and what is the reactant and what is the product. We are doing these things to better understand reality. It's one of the things that we can do to better understand reality, and or I shouldn't say, I guess reality works, but the natural world, natural phenomena, and so what we observe and how it corresponds to a biblical earth is, for starters, we have this four light picture which I've shown before, and this is actually from a video, and this is an experiment which shows four lights in a straight line, and these lights are a foot high, and they are 5, 6, 7, and 8 miles away, over a frozen lake. And so what do we see when we observe from an observer height of less than 1 foot? So this camera is actually angled slightly up, uh, which you'll be able to determine that from measuring, because what we observe is we observe all four of these lights in a straight line. They are planar, they are parallel to the ground, and they are level and flat. And this is, I might have to edit that last word out. Mm, maybe, possibly. Um, so these lights, what they show with reality is that they show that over water, it's a parallel characteristics, and so that's what we see. Four lights in a line. Now, biblical earth claims that water will do this. Characteristic of water is to seek its own level. Water is always looking for the lowest potential energy. It's also called resting energy. So it's looking for this lowest level to rest at, or have the greatest potential energy. And once it gets to this point, it will. This is what it means by it seeking its own level. All of these molecules are being influenced by this force of the seeking of this lowest energy level. They're following the energy is dictating where they're going, and so they're all trying to get as close as they can to their lowest resting energy, and the water molecules below them get in their way. And when you're at the very surface, everything is planar. That's the interpretation. It matches the characteristics. It matches the things we know about other things, about the behaviors of water, and so we can. Uh, it's it's showing the earth resembling what the Bible says, and so this is our experiment. This is the data, or this would be we have the data with the four lights all being in a line, and now what that was with the water characteristics and everything, and the lowest potential energy, and the planarity of water, that is all conclusion. And so that is what we interpret off of that. That it would be, well, if you want to go with philosophy, Occam's razor, the simplest explanation. The lights are in a line, they're parallel, the water is parallel, it measures parallel with these lights. Uh, and so, what is another interpretation? Well, the taught model of cosmology is the globe, and the globe is an oblate spheroid, which is um, not perfectly spherical. And if you looked at a cross section, it wouldn't be perfectly circular, uh, but it does have continuous curvature. And there is an equation for this curvature. We know the circumference at the equator, and we can measure how much curvature there would be. It is a ball, and so it has continuous curvature, uh, even over the surface of water, because water is the surface of this ball. Uh, excluding the atmosphere. So yes, over land there is hills and valleys and mountains, certainly, and even different changes in the slope of the ground. Uh, so that's why over water this is done, and we see that it is planar. So this is what we measure, or what we show, what we observe, what we interpret, and what the globe claims is that there is water that is curving. It is convex. On the outside of a ball, it is the surface, if we don't include the atmosphere again. But they say that goes out to the moon, uh, which might explain why the transparent moon shows blue sometimes when it's day, or shows blue when it's day and black when it's night, or dark when it's night, darker than that blue for sure. So uh, we need to observe this. If that's what you are claiming is reality, then we need to observe this convexity of water. And to do this, those lights would need to have drop. If you are looking out at them and you're the observer, you're the central point, everything is dropping away from you in all directions. Everything is going down, sloping away gradually, and at these distances of 5, 6, 7, and 8 miles, there should be curvature enough to hide each of these lights, um, actually by quite a bit. And so these lights, you can see them all. They're not even beginning. There is no difference in height between the one at 5 miles and the one at 8 miles. And there needs to be, if the Earth is in reality in the natural world a ball, and that's what we're taught that it is. Uh, this is an experiment that doesn't align with what we are taught. So if an idea is incorrect, you have to alter it to fit the data, or you have to get rid of it. And the attempt to rescue the globe is with this observation is that they say that it could be refraction, um, which light. So when you're doing spectroscopy and you're measuring light, you are going to have standard conditions, and anytime that it is cold, you actually subtract. So 20 degrees is the standard temperature centigrade, and when you subtract 1 degree, you subtract 0.0004, and so you're actually lowering your refractive index, and this is so this bends light downward. And so these lights that are away from you, if you're going to say refraction explains why we can see these lights parallel, refraction bends the light down. So if these lights are below you, they're below your eye level, and then the light is bending down, you are going to the light is going to run into the curve of the Earth, and it's not going to reach you. It's blocked by curve. Just like at 3 miles, we are told that a 6-foot boat is hidden by curvature. And these lights are 5, 6, 7, and 8 miles, and they're not blocked by any curvature. And the thing is even if you with the light bending down with refraction, um, you are still uh, you still have there's something else to this, is that it is cold, and refraction is minimized when it is cold, because when it's cold, there's not as many particles of water in the air. The water vapor is all frozen down on the surface of the body of water. It's not when in the summer when there's a boat on the water, there can be more refraction actually because of the evaporation of the water puts more water into the air. Some more, and that's creates more lenses, more microscopic lenses, and these particles can help with the refraction to increase the refraction, the magnification of the lensing of the water particles.
Same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is like acting like a lens.
So this experiment is done in the frozen temperatures of the winter actually does help show that it is not in a refractive effect. It minimizes the refraction. So you can use this as an explanation, but it matches more succinctly, logically speaking, um, from what the Bible claims. And the evidence would suggest that the Bible claim is right because you do have the cold temperatures from reduction of the refractive index and the reduction of the lensing particles in the air. Actually, it actually implies that it would not be possible or for a globe. So we definitely see these when they shouldn't be there. And so this shows the planarity of the biblical earth over water, which is, so we're told, 70% of the surface. So, and that's part of when people talk about this subject is that it's the water itself that reveals. Just like if you put water in any container, it'll take the shape of the bottom of the container of the basin that it's in. At the surface, though, it will be level across a wide body of water at rest. If you want to get technical, because there are actually certain instances where if water is on a hydrophobic surface, it will ball up because it doesn't want to be, the surface and the water don't want to interact. Like in a hydrophilic surface, hydro being water, philic meaning loving, so water loving surfaces will pull water out. Hydrophobic or water fearing surfaces, water will ball up a little bit, it'll bead and get a little bit of convexity to it. But the water on the globe isn't doing this. The water isn't on a hydrophobic surface. There can also be meniscus in narrow tubing where, because of the surface tension of the water and relation to the glass that it's in, typically with like a test tube, the water will actually adhere to the test tube and it will pull itself up on the sides of the test tube and form what's called a meniscus. And in science, they actually measure from the bottom of this meniscus, but this meniscus is, that's where you take your measurements from if you're measuring something out, and it forms this. If you get this meniscus, this is concavity. It's going the opposite way of a ball, so this one doesn't really matter as much because it's not what the globe even claims, so it's irrelevant. But it's another type of disturbance or warping of the surface of regularly under standard resting conditions. It's what distorts the planarity of the water. And so you have this meniscus, you have the hydrophobic surface. The other time that water is basically not planar is when it's not at rest, when it's in motion. If water is falling through the air in a droplet, it's going to ball up in a circle or in a sphere because a sphere offers the greatest surface tension to the water. It's the easiest energy efficient shape to take. So it will ball up just like it does on the hydrophobic surface. But water, when it's in a body of water in a basin, is not moving like this. So that is also a false comparison. The other thing that the Earth claims is that the biblical Earth claims is that there is no motion, and so this motion, lack of motion, or this lack of motion is shown when we take a mechanical gyro and we spin it up to many thousand RPM. This gyro will um, when we spin up, it is supposed to do something that is it has mechanical gyros have a characteristic, a property of them is something, or something that they do is they exhibit what's called rigidity in space. So if you have a gyro, no matter which way you turn it, it will rotate, but the center axis will remain in line however you have the axis oriented.
So spin angular momentum has the property of stabilizing things. And you will see that addressed in one of your assignments when I want you to address that quantitatively. This is the basic idea behind inertial guidance systems. In inertial guidance systems, you have a spinning wheel, at least in the days that the guidance systems had mechanical wheels. But that spinning wheel is mounted in such a way that you cannot put a torque on the axis of rotation of the spinning wheel. That's the way it's mounted. We call it three-axle gimbaled gyros. So the moment that you put a torque on it, the housings, in this case the yellow and the black housing, will start to rotate. And you never manage to get that torque on the spinning wheel. You never get it on this axis. And therefore, if now you put it on your boat, or you put it in a plane, a missile for that matter, if you can never put a torque on the spinning wheel, and if the angular momentum for spin is in this direction, it will stay there forever and ever, assuming that we have no frictional losses. And if then the plane turns, the direction of the spin angular momentum will not change. But what will happen, of course, is that this yellow frame will rotate, or this black frame will rotate. And in these bearings here are shaft encoders. And they sense the rotation that the outer housing makes in order to keep this thing pointing at the same direction. And that signal is being fed back to the automatic pilot, and that keeps the plane flying in the direction that you want to. So you use as a reference all the time the spin angular momentum of your gyro, which is now mounted in such a way that you cannot put a torque on it even when the plane changes direction. And I want to show that to you. Well, okay, this is the direction of my spin angular momentum. And I'm the airplane. And I'm going to fly. Look at that spin angular momentum. It has no respect for me. It stays in the same direction no matter how I fly. And the error signals that come from the bearings of the yellow housing and the black housing, those arrow signals are fed back to the automatic pilot, and so the plane will stay on course.
Videos on gyroscopic navigation and all of that. I had a couple of points I wanted to add. The first one based on a comment that I just got, which just really blew me away. It's so simple, and yet it's... However, it seems you could also prove this by never leaving home, unless there's something I'm not understanding. If you were to just set the gyro in a gimbal base where it could move freely and then put it in motion with its axis in a vertical position, in the next 6 hours, wouldn't you see the axis slowly move to a horizontal position at the base as the base rotates with the globe Earth? If it doesn't, then the Earth is not a spinning ball. Okay, so after taking a few seconds to let what he's saying absorb, I was like, holy cow, I think... And you would think they would. I mean, right there in the film, he's saying that the gyroscope resists
in 3D space. So everything around it will rotate except for the axis will stay upright. Or if you have it upright, and then you can turn it in any way, the outside caging, and it will still remain upright. And so when we spin these gyros up, they should, because Foucault, who has the pendulum, actually claimed that his gyro could detect motion to the Earth, the rotation of the Earth. If the Earth were rotating and we had one of these gyros spinning for 6 hours, the Earth would rotate 90 degrees. And so there would be a 90-degree change in the axis compared to the caging of the gyro, of the mechanical gyro. And so these gyros actually do fail to detect motion to the Earth. And so there is... this would be a way to do it because it's mechanical. It's strictly influenced by the physical mechanical properties, which are claimed to be rotation, but it shows no rotation. You can have... There are other gyros that use like lasers, and they're called laser ring gyros, ring laser gyros. There's also fiber optic gyros, and those use light, but those could also be influenced by magnetism and the ether, which, you know, the Earth's magnetic field and the ether rotate as well. That's what's rotating on in the biblical Earth, is the heavens above. And so what this means is that essentially the mechanical things that are supposed to show physical motion to the ground, to the rotating globe, actually come up with what they call a null result. This is especially true of like the Michelson-Morley experiment. All of these experiments that we have done to try to show motion, other than using like an apparatus like a gyro, um, they all show that there is no motion, which is why Einstein, who is the premise for basically modern cosmology and our understanding of the universe that we're taught in academia, he did declare that there is no experiment. There's nothing we can do if we are rotating on the Earth to show motion to the Earth, because it's all relative motion. There's no inertial reference frame. The Earth's motion is relative, and nothing we can do can detect this. And this is... You had Foucault talking that his gyro could show the motion of the Earth. Foucault was he claimed that his gyro and his pendulum, and that's what he's known for, is his pendulum, that they could show motion to the Earth. And Einstein knew this, and Einstein still said there is nothing we can do. Einstein would have known about Foucault. And he said there's nothing we can do to show that the Earth moves. And this was actually in part to respond to the Michelson-Morley experiment, which he did state if we accept the Michelson-Morley experiment as a null result or as a failure, which it wasn't. You can't. The experiment showed what it showed. There's no failure. It shows what it shows, and then it's an interpretation. It can only fail if you're biased and you have a presumption that you assume is correct, and it shows what is not true of your model. So you have Einstein himself saying there's no motion, which also matches what we get through experimentation. And yeah, there are things that you can do to that. So what? There's basically no. There are things we can do to determine these physical characteristics and these properties to the world that we live on, and they do always align with. These are main critical point claims that help determine the cosmology that we live in or exist in, and it matches biblical cosmology. And this is the reason why, like, you can talk about the sun and its position or the stars or this or that in the sky, but where the globe and the biblical earth are at odds with one another, where they're diametrically opposed to one another, uh, that is going to be in what the earth is. The sky is another thing entirely. And so when anyone does a test to determine if there is curvature or if there's motion, they get a 0. If you get a no. If you do an experiment with if you go into an experiment with that, uh, you know, people would probably call it bias or your presumption, whether you know it's there or not. Which is, in science, getting rid of those things is actually can be difficult for some, especially if you don't even know they're there. So if you go into an experiment and you're already knowing uh, that your Earth is a globe, you're going into the experiment with bias because the Earth being a globe is what's in question. If you knew the Earth was a globe and then went into an experiment to determine something, you would have to interpret it through the Earth being a globe. But because the globe is being questioned, you have to show that the Earth is a globe. And we get a null result when we look for motion or curve, which a globe has. We get a 0 going in with that bias. If we go in with the bias that the Earth is biblical, uh, or the presumption that the Earth is biblical, we get that that it's a match with our experiment, with our data, that water is planar and that the Earth is stable and fixed and shall not be moved. If we go into the experiment with no bias, with just going what is strictly is the data, we see 4 lights over water in a straight line, and lines are flat, level, planar, etc. And we see that a gyro remains in the same orientation through time, through 6 hours, and that it doesn't show any motion to its placement. So there would be no motion and there would be planarity. That's no bias. Now, then it would be who says what. So that's through conclusion, through interpretation. So, those are the differences in the claims and what we get to. And there's a philosophy to this as well, as far as like the why and the who and the how. And maybe I'll do that next. I don't know how long to make this, and this is already getting kind of long. So maybe I'll cover the philosophy next of the why and the who and the how and that, because that is important. But you have, if you're looking at it strictly scientifically, the Earth is what it is shown through experimentation, and then we can interpret based on that. And some people have biases, and well, I mean, we might all to extent in some areas, but we have to let the evidence speak for itself and then interpret from there. Everything in science is up for critical analysis and can be probed for strengths and weaknesses to any idea. And then we carry out ideas through experimentation. We gather the data, and does it corroborate with the idea? How do we interpret things? Where do we go from there? Can we ask more questions? What can we do? This is part of the scientific method. And when we do all this, we show that the Earth is biblical, matching in accordance with our scientific experiments that we can do today with our technology. Okay, I am going to sign off for this one. Thank you, everybody, for your time and for listening. Let me know what you think, and Jesus Christ be with you all.